So we're going to give this a try. My cat having a fit. Sweetheart. All right, so you've done the mathy approach. You've done the mathy approach to looking at this graph. What I want to do is take a couple seconds to take a sort of a quick and dirty look at it, not from a mathy approach, but just from using your head approach. And so let's see how that works. So what we're going to do here is to try to make sense out of the motion of the body, doing nothing but looking at our position versus time graph, and not using any kind of math equations that you've memorized at one point in time or another. So along this section of time here, you will notice that the body's coordinate is -8. It stays that way throughout this entire section of time, which means the body's not moving. Its velocity is 0. Right around here, going all the way over to about here, you will notice that the body's coordinate is changing. So at this point, the body's coordinate is -6, and at this point, the body's coordinate is -4, and at this point, it's -2, and 0, and 2, and 4, and 6, which means that the body is moving. It has velocity. And in fact, the velocity is quite uniform, so it's basically a constant velocity, which means there's no acceleration going along with this motion. The body has gone from no motion to some motion, which means through this section there must have been an acceleration. Up here, the body is moving with some velocity, somewhere around, I don't know, the 15-second point, give or take. It changes its motion, and now through this time section here, the coordinate is 8 meters throughout, which is to say the body is stopped, the velocity is 0, which means we have a velocity change. Here you had some velocity, here you have no velocity, and which means you have an acceleration through this section. So simply by looking at what the coordinates are doing, what the body is physically doing as far as where the body is as time proceeds, we've been able to deduce that up until around 5 seconds or so, the body is sitting still at y equal to -8 meters. It then proceeds to accelerate, and from about 6 seconds to about, 15 seconds, it moves with a constant velocity. It moves from the negative region at t equal to 10 seconds. It goes to the origin. It continues proceeding until, as I said, about, 14, 15 seconds, give or take, at which time it accelerates again, slows to 0 velocity, and proceeds to spend the rest of its life at y equal to 8 meters, stationary. And that's pretty much its motion. And we've done this essentially without using any kind of formulas that we've memorized in our math classes. So the moral of the story is this. There are two basic ways of taking a look at any kind of graph. You can approach it from kind of a mathy perspective, and you can use the relationships that you've developed in your math class to figure out things which are quite useful. For instance, you might want to know what the slope of that line is, because that slope will give you what the velocity was over that time interval, and that's something you might want to know. And so you can use math on a graph like this. The other alternative is to not use math and just to use your head. And if all you really want to know is, what the motion of the body was in general, using your head works perfectly well. Each approach is perfectly useful in its own context. This exercise was wrapped around the using your head approach, and so that's pretty much it. So this is a little more formal presentation of the things that we've concluded. If your assignment had been to, describe the motion of the body using a, seat of the pants, use your head approach, which is kind of like what we just did. These are the sorts of things that you might have written down on your graph as you were thinking through the process. Again, though, the main point is is that all the information that you would have accumulated um, would have been done by, just thinking, just looking to see what was going on, what the graph was telling you, and not depending on, mathematics that you had pretty much memorized in your math classes. Anyway, that's it.